Hey, good afternoon, everybody. I hope everybody's doing well and having a fun time at NoSQL Summit. Truly dedicated to come out for NoSQL Summit. No, this is a really good crowd and been a lot of great presentations. So happy to talk to you today. Just to give it everybody a heads up, if you throw me softball questions at the end, you can come up and I'll give you a sticker, a NiFi sticker at the end of this. So we really do want participation. My name is Henry Sowell. I'm the Tech Director of Cloudera Government Solutions. I'll give you more introduction here in a second.
I'm Tim.
Yeah, Tim's great. Today, we're really excited because this is something that is near and dear to my heart. We're going to be walking through tracking crime as it occurs with Apache Phoenix and Apache HBase, and it all being fed with NiFi. So we're going to walk you through multiple demos, walk you through the architecture, and talk to you about how the solution can work in the real world. A little bit of background about me. I come from, been in the public sector space for the last 16 years. Was in the Marine Corps Infantry, fought in Iraq, did a lot there, did a lot of intel collection, tracking down bad guys while I was in that space. Joined the FBI, worked at the FBI for almost 10 years, and I was doing counterterrorism work, tracking down bad guys. So as you can see, I like to track down bad guys. It's really important to me. So this topic, when it came up as a potential talk, I wanted to jump onto it because it's just so important. And I came out and worked with Hortonworks and now Cloudera, helping public sector missions across the United States and working on these different topics.
Hi, Tim Spann. I don't have as cool a background as Henry, but I was at Hortonworks. Before that, I was at Pivotal. Did a lot of stuff with data integration, data ingest. I also have a background in IoT, deep learning, and streaming. I come from our field team for data in motion. But you know, when you're doing data in motion, you got to store it somewhere. HBase is now extremely easy to store data into from NiFi. I'll show you in the demo. It almost makes, to me, HBase the preferred place for me to store data now. It's so simple.
So what's going to happen today? What we're going to start with is using NiFi to ingest a whole number of different data sources that we're going to walk you through. And these data sources are crime events as they're occurring, dispatching, cameras, all kinds of different things that can help us to make different decisions on the infractions that we're seeing. We're going to be able to do and show alerting, routing, and reaction to the events as it's coming. And then where do you land data and perform this kind of use case? And we're going to talk about how Apache Phoenix and Apache HBase are a great way to both access and store this data. And then we'll show you actually live populating the tables and how easy it is and how fast it can be.
Oh, this is my part. Okay, so Cloudera sells what we call data flow. It's a data in motion platform that helps you get data wherever it is, do some processing, and then eventually, we were at NoSQLCon, push it into HBase, Phoenix, and possibly a Cumulo to store it and do your analytics. But it's very important to have integrated open solution that lets you ingest all these different types of data, do processing on them as they come in, route them, make decisions as things happen, and not wait until they're stored and then you run queries at some later point. The main things you could do here, you know, spans the whole set of platform that we have out there. It's really important that all these guys work together because you can't really start building a data warehouse until you get that data. And the data could be sensors. Today we'll show you we're grabbing government JSON feeds, XML feeds. We're grabbing live traffic cameras. We're grabbing Twitter data. All these different sources of data are out there. There are different types, different fields. They change. The data comes in really fast. You know, millions of messages. We can handle this all on this one platform we have. and it lets you bring it to that next level where you say, okay, now I'm going to start doing predictive analytics on this to figure out what's the next thing to happen, how do I allocate my resources. We'll get further into the use cases, why this is important in the field of crime, but it's for anything. I mean, and almost anything you're doing is starting to add real-time components, whether it's from a phone app, logs from any application, sensors, cars, all kinds of devices. The main tool we'll show today is Apache NiFi. This is an open source tool that came out of the NSA. It's rock solid. It's been out for more than 10 years. It's very easy to use. We'll walk through how to do it. It also has some nice features if you're coming from a development background. It has a full ability to do DevOps, full development lifecycle. And if you look at the screen, it's extremely easy to work with. That is not a diagram of the tool. That is the live tool you use to develop code. And the part that people really love with NiFi, because it's so extensible, we have over 300 different processors to do things. And this is, from one side, these are all the sources and sinks you could deal with. You know, FTP, files, email, pretty much any data store you could think of. The NoSQL stores we talked about today, and other NoSQL stores out there, all the SQL stores, any kind of event messaging, email, WebSockets, logs, and what you could do with them. I mean, there's some basic things. Routing is one of the most important things. So I could take all these different sources, do some processing on them, convert them to a different type, then route them somewhere, which could be, let me send an instant message, let me store that in HBase for analytics, you know, let me split the data apart, combine it together, do different analytics on them to figure out where things should go, and do that in a very simple graphical manner. So I came up with a simple architecture on how to do this, and it's all implemented, and we give you, I'll point you to the GitHub. Everything is open source. You could take it, play around with this, apply it to your own data. As you see here, the sources are pretty extensive. I don't have them all in this particular demo because it would take too long, but we are pulling in REST feeds. I'm pulling in news feeds. We're pulling in camera sources, Twitter, but we could pull in things like PDFs, Word documents, pull text out of them, run natural language processing on them, do a lot of different things, and NiFi is your gateway to do that. It's running our event processing, and I'm pushing a bunch of that data into Phoenix. I'm also pushing some of that to HBase, as you'll see how easy it is to store data in HBase from NiFi. We have some other tools in the platform to help us out for things like operations, governance, and security. As we mentioned, this came out of the NSA, so security, logins, permissions, all that sort of thing is very important. And in NiFi, we could actually encrypt data, not just with SSL. We can encrypt data at each step along the way. So as data comes in, I can encrypt it. When it comes out, if I want to decrypt it at the other end, or push this into encrypted HDFS, I could do that. Lots of different options for analytics on the other end. So I could do dashboards. I could export it to Excel, put it in Tableau, any of those kind of analytics tools. You want to do that next step is you're able to get that data real time, make alerting and decisions on it. But how do I start using that accumulated data for, you know, deeper analytics?
So when you look at, this is one of the feeds, this crime JSON, and so what you're looking at here is a dispatcher feed that is coming from the city of Philadelphia. So anytime somebody calls the police and reports a crime, hey, I've just been robbed, a dispatcher collects, marks the event, sends it off to dispatch the police. And this is the file that gets created. So you have several things that are in here, the date, time of the event and the dispatch. You have what's called a location block, and think of that as if you're on a city and the block and where they were deployed and where the event occurred. And then you actually get down to GPS coordinates. So you've got a point X, point Y here. That's GPS coordinates of the actual event. And then you have the ability to have different types of GPS shapes. So in this case, most of them are points, but you could actually have something where you have a vector that goes around a specific area as well.
Yeah, so what's nice about this is it's JSON, a very common format. But with NiFi, I don't really care what that source format is. It's very easy for me to take that and push that to HBase and push that to HBase in a format that's nice for HBase. I'm not just going to drop this whole JSON inside of it and let you try to figure that out later. I'm pushing this natively to a Phoenix table and pushing it natively to an HBase table, and I have it formatted properly for HBase. It's not just a dump a JSON into there.
We're going to be juggling back and forth between the presentation and demo, so bear with us.
So this is Apache NiFi. What I'm showing you now is a bunch of different places where I'm ingesting data. And one of the easiest places for me to ingest data is from social media. So I'm analyzing Twitter. I'm looking at the feeds for the Philadelphia police, Philadelphia FBI, all their news channels, and some other reputable sources of data. And I'm analyzing that for some keywords, pulling that data in. When it comes in, I'm cleaning it up. And then, as you see here, this is how hard it is for me to take a Twitter feed and store it in HBase. It is pretty simple. This is the code. We have a generic JSON reader that reads that JSON that came out of Twitter and pushes it to HBase connection I have. As you can see here, there's the table name for this table in HBase. There's the row identifier. There's the column family. And I can decide how much I want to batch these up and a couple other decisions on how to store it with HBase. But I don't really have to make too much decisions on that. And if you look at the numbers on there, it's been pushing some data in there as I've left this running. What you're seeing now is one of the features for NiFi that make it very important for distributed programming. We have what we call data provenance. This is a record of every step your data took. So something like crime, you might want to know why did we apprehend someone, and here we could say every step that data took before it was saved. So I know who touched it, how big a file was. So if someone goes back and says, you went and you changed that data, I could tell you what was the file size, when I grabbed it, who touched it.
Yeah, imagine if you were a police department, right, and you went and arrested somebody. And they said, why did you arrest somebody? Well, in the dispatch record, I had a name, address. I looked that up automatically with NiFi and went against my DMV records and pulled up his last three addresses, and we said that he had a likely location at one of these places, right? So we can actually track, yep, we knew at this date and time, this is what was enriched, this is the data source that it came from, and when you go and build that case, you have a whole set of information about why that decision occurred before you actually provide it to, that you can provide back to answer those questions.
So something else we could do in NiFi, data that's coming in through the system is live. It is living data. So I could run real-time queries on the data as it's flowing through the system. And this is an example query where I'm querying that Twitter message. And if it contains the keyword theft, I'm doing additional things. I'm pushing that directly to a Slack message. And I'm pushing a lot of different messages to Slack because that's a very easy way for me to push data places. This is also showing you some of the messages that are coming from the web cameras. I'm also, besides just reading those web camera images in, I'm also pushing them through a TensorFlow analysis to look at those and see what's in the picture. You know, obviously that's something where you might work with data scientists to come up with your own model. So if you're looking for very specific things in a picture, especially for cars, maybe you're looking for license plates, maybe you're looking for certain color cars, trucks, different things. You can make a model that just does that.
Yeah.
So we're pushing that to Slack. We're also pushing those messages to some of these tables we have in HBase. If we looked here, where were we storing those? We're storing those to Twitter. There's a lot of messages in Twitter. So we're breaking it down. It's just stored regular HBase. I've been running this for a couple hours today just to see what data is out there.
And what I really like about what he just showed, right? So we have the ability to route this in many different directions, right? So dispatch comes in, police get notified to go maybe issue an arrest, and you send an alert to the jail that says be prepared for potential receiving of an event, or send something to emergency services because there's somebody that's injured, right? So you have the ability to do many different things other than just storage. It's an incredibly robust system.
Yeah, and for something like grabbing REST feeds, which if you're involved in anything, there's a ton of public, government, and you'll find private and paid REST feeds out there. It's extremely easy for me to read any REST feed, route it, convert it to whatever I want. I mean, this is the flow for me grabbing. Here I'm grabbing from the Maryland road system some of their car incidents as they happen, and then I could just push them right into HBase. That XML will automatically be converted into native HBase records. As you see here, it'll convert it just like this, using the timestamp, the column we mentioned, all the things you expect in HBase, nothing weird in there. It doesn't try to squeeze one big field. It breaks it out pretty intelligently. And this one will do it from XML. We have readers for a number of types here. I could read Avro, CSV. Grok is pretty much any semi-structured text. JSON, we could do a couple ways. Syslog, XML. The scripted one, you could write a small script in a couple different JVM scripting languages. So if you know how to transfer your data, you could use that to build records, and then we could push them to HBase here, but we could also push it to Hive. We could push it to Phoenix. We could push it to a lot of different places. I mean, the main source of the data here, as you see here, Baltimore, DC have slightly different formatted XML JSON than Philly. So I'm sticking with Philly. And it's pretty easy to grab the data. You'll see a lot of the open government data sources will have these REST APIs. And you pass in a date format. You get the data back. We could support SSL if it needs to be SSL. So the data comes in. Here I'm breaking apart the JSON. I push it right to, if I just wanted to take crime data, push it right to HBase, it's 3 steps. Take my JSON, push it to HBase. Here's the row identifier. Here's the column family. If we scan crime, here's some of the records from crime. Here's the values. And obviously, any kind of HBase thing that you're doing, you could easily use this to populate it. So if you're using it for another system, it's right into HBase. The other thing I'm doing here is I'm pushing it to Phoenix as upserts. I don't have that set right away. Don't look behind the curtain there. So this is as hard as it is to pull in the JSON data. And what's nice thing with NiFi, I could schedule this any way I want. I could have it run continuously every second. I could put a delay there. Most of these REST feeds don't like it if you call them every second, or have 16 servers call you concurrently every second. So we can set these up at an interval. We could also set up a cron schedule. A lot of people will convert existing cron jobs they have, which could be shell scripts or Python or whatever you have, convert that into a NiFi job, because now you've got a flow to see what happens. You can handle errors intentionally. You have logging. You have the data provenance. You have all this in one place. Makes for a very easy way to do this processing, and it's very straightforward to do that. And in the last one, it's just as easy to grab cameras. So what I'm doing is I'm passing in and I'm executing. I have a batch of URLs, which I could feed from anywhere. I have a hard-coded list of a couple of different traffic cameras in the Maryland area. So if you guys are speeding, I might have got you here. So when it comes through, if there's an error, I send it to Slack. If there's no error, here I'm checking to make sure that it's a legitimate size file. If an image is too small, doesn't make sense, then I push it to my TensorFlow processor to do object inference on that image. It's not extremely reliable. I'm using out-of-the-box image. If you look here, something we didn't mention is when you have that data, I can make sure it's never changed as it comes through the system, but I could still add value to that data. So we have these attributes, which are metadata around your data. The data won't change, but I could add these metadata values around here. And some of them here, you can see these labels. Those are the results of the TensorFlow deep learning analysis of those live traffic camera images. So I've added all that metadata, plus a bunch of other metadata from the system, like, well, what was the server that was hosting that web camera? What's the URL? You know, all that sort of information is there, content length, but I still have that actual image. There's the actual image. So NiFi is handling the image, all the metadata around it, XML, JSON, PDF, Word, doesn't really matter. It could be coming out of HANA, coming out of a SQL data store. It's just data to me. Very easy for me to do things with it.
So imagine a scenario where dispatch gets called, an event happened at X time, and we were monitoring feeds on that road, and we can immediately identify, hey, there was a white sedan, you know, a black pickup truck that were in that space at the time of the incident, right? Hit and run then becomes much more narrowed down to, could be anybody, but it could be these two things, right? And that allows you to make intelligent steps.
Yeah, things like these camera images, a lot of them are updated every second. I can grab them every second, track a white truck between the different cameras, and feed that real time to say, I'm following this truck. It was on camera 7, which is 14th and Elm. Now it's over here. Give people some real-time reconnaissance. Obviously, I've got some clients in other cities with faster feeds and better data. With that, we can really track things real-time to say, this license plate is on this block, this block, this block. Combine that with a crime data, marry them together, put that in HBase for later analysis to say, this kind of thing happens. We're grabbing the weather data, social data. You put all that data together, you could start not only making decisions really fast, start making, you know, future planning. And
Our job here is to connect with some of you and creep out the rest. Well, when we get to the Q&A section, we can talk on that side.
Now, all the data we're using here is open public data that's available to the general public now. You can go to Open Data Philly, and they provide all the crime feeds. All the traffic cameras in America are open, that you can go to a website and see them. This is just data that's available. Now, if you used private sources of data, which many companies do, you can use that for whatever uses that are allowed by, you know, your agency or whatever you're working with. But as you can see here, it's very easy to grab this public data, do things with it.
We had backups when everything broke.
In case, yeah, things didn't break.
Hey!
Which was a miracle, live demo, and the network didn't fail. So you store the data. Some of the problems people have had with HBase and Phoenix in the past is, I have the data, it's not Oracle, it's not HBase. How do I use it in an application? I want to go microservices. So I have a small Spring Boot application that's hitting this table and able to access this. And I compiled this yesterday. And this is on the latest version of HTTP. with the latest version of Phoenix 5 something, 5.0.0 something. And it's working perfectly fine. I've written some articles and have a GitHub around that. So you could see that. Let's see if it's still working. NiFi is very solid. Spring Boot. OK, here we go. So I've got a very, very, very simple web page that lets you do queries against that Phoenix data set. And it's a very simple REST API. So I just do a query and pass in, I don't know, let's see, salt. Here's some JSON data. Obviously, this microservice can be called by another microservice that wants to ingest that Phoenix data without knowing what Phoenix is, what HBase is. It's just a REST API source for people, gives them JSON. So we had JSON come in. I stored it in HBase, native HBase, stored it in Phoenix. I didn't show you the Phoenix table. Let's look at that one. You know, native Phoenix table, nothing stored weird. It's not stored as JSON. So I pull it out of there. I pulled it out with a Spring Boot application via regular JDBC, thanks to Avatica. And now you have a REST feed. We rebuilt JSON. If you wanted it in XML, you wanted it in some fancy format, we could do that.
Yep, and think about the power of this too. That the Spring application that he wrote you could also leverage NiFi to enrich data that you're bringing through the system as well. So, what do you do after you collect it? What happens then? And the biggest thing is that it's not just the data that you're collecting; it's also gaining actionable intelligence from that data. You know, one of the easiest things to do is to visualize the data, to put it into reports. These are just a couple examples of things that have been created. Like this is an example of crimes reported over time over the last month. The number of crimes reported over time. Plotting the points that we're collecting onto a map. Creating heat maps of the crime and activity that's happening. Those are all basic pieces that you can do and that should be done. The next step, though, is starting to make decisions around that. Optimizing the allocation for police resources is a very big use case. Think about, you know, a high incident area. We could deploy more police in that space, making sure that we are providing enough assistance to that area. It doesn't have to just be police, but it could also be other resource, community events, building up that community, working with the local the local city to make initiatives in those spaces. All those kinds of things can be driven to deploy resources in these areas to make decisions. You can also use it to analyze trends, right? Hey, after every major parade event, we have an increase of theft and breaking in of vehicles within this specific area. Well, now we can make decisions that we have an upcoming event. We deploy resources to those areas to lower theft and crime in that space, right? So you can make good and timely decisions to help assist with resource allocation. The next piece is data-driven policing. So we talked about this a little bit, but imagine the amount of data sets and data sources that you have at your fingertips that we've just talked about here. There's many others. Imagine if you have a dispatch that there has been an assault on a street corner, and you're sending police out to that street corner. What are some things that you might want the police officer to know? That is a high crime area, that there have been multiple shootings, that there is a reported gang territory in a specific space. That might be something that would be very valuable for the first responders to make sure that they're operating effectively to help the individuals that need help as soon as possible. Think about if you're an investigator and you're an investigator and you're tasked with finding somebody that has murdered another individual. Well, what is the basic information? Well, we have an address. We have an address that was reported about the specific individual, but man, we have so much more data. And oftentimes, part of the problem that that we see is that we consider individuals by a specific item, right? Like, hey, you're an email address, or your phone number, you're an arrest warrant, you're all these things. But who in here has more than 3 email addresses? Okay, who here in here texts? Right? What about, do you go on social media? Do you like to talk to your friends? Right? You see, you see that there's a huge amount that says just like each one of you generates a ton of data and a ton of information that helps you to identify who you are and what's important about you. And we really have to say that, like, to understand this space, to do better policing, we need to understand more holistically about individuals. And this, in doing data-driven policing, is enabled with these types of platforms. But the next step is, we don't want to keep reacting. We want to make some predictive decisions, right? And so that we can make better informed policy. We can create better informed policies. We can create better responses to potential events through machine learning. So we can analyze a whole corpus of data that we may not have understood that a factor was potentially involved in the increase of crime, like the weather, right? Who knew that if the weather gets above a certain temperature, that people get frustrated and they get, and that you see an increase of certain X amount of crime? Well, you don't know, but there's certain factors that we might be able to address, and machine learning can be a key component of that. And then we have the ability to add a huge amount of additional data sets that can help feed into all of these areas to make better decisions about our data. So you need a flexible platform that allows you to onboard data sources very quickly. You need something that is scalable, performant, that you can easily query, like HBase and Phoenix, and they all enable the crime fighting. So I think with that brings us to the end of today's talk. I think what we've shown today is that there are easy ways to move data, to bring it into HBase, that HBase is an incredibly effective tool for retrieving this data, that it can help enable crime-fighting missions and other mission sets that you might be dealing with yourselves. With that, thank you very much for being here, and we'll open up to questions.
Are you guys going about validating everything that goes through NiFi is actually making it through HBase?
Yep.
Also,
So how do you?
Repeat the question.
Yep. So how do you validate the data that you're moving is actually making it to HBase? Is that correct? And then how are you also handling error events as they're going through?
Oh, he wants an answer. Okay.
Yeah, you're the guy.
Oh, that's me. Okay, so
Here's the bus. Here's you.
we have the size, and we could also do MD5 hashes and checksums at different steps along the way. As part of the data provenance, we have the size and the number of records from ingest to the end. And we could check that data as it sees attributes. Everything that's an attribute is accessible in NiFi in a coding manner. It's also available that I could push it as a feed to something else. So say you have a system that's designed for validating data, I can push that feed to you if you want to do it. Otherwise, I could do that right within NiFi to say, okay, let me look and find the file size and number of records for this particular ingest at this time. And as it goes through the system, I could code on that, and I could route on that to say, if the number of records now doesn't meet that original record count, send an alert, don't store it. I mean, whatever options you have. And at every step of the way in every part of this, we have multiple relationships. It's not just the success one. We usually have the success one, and for demos, it's nice to show the happy path. You know, obviously there's a lot of unhappy paths. And when you have those failures, like say you send me bad JSON, it could happen, something broke, so I might have to do something with the data or tell somebody. So if I get a failure, do something. And I could set up a standard processor group to handle certain kinds of failures, and I could put that in one place. Or it could just be as simple as if it's a failure, put it in another HBase table, and then someone's job it is to check that. Or I could do the count. I could also check not just the count, I could check the record count, size of the file, size of each row. I could check every single field in there for certain attributes. I can do different hashes on the data as it comes through.
We often have that happen where like you saw on the image piece, right? Where he was looking for specific sizes, right? Anything below this is not a valid image. He could throw an alert that says, hey, I have encountered, you can either log it, right? Or you could send it as an alert to Slack or email or send somebody, have somebody called or phone.
Call a REST
right?
API.
Yep, and so you can do many different things. You can set that into ticketing systems, but you can validate the record as it's in flight. You can also do things like measuring that, hey, I'm expecting that I'm going to have a threshold. I expect that I'm going to receive 1,000 messages an hour. If I fall below a specific piece, generate an alert on that, right? If I have a flow that's running that talks about if I have not seen an alert within 2 hours, I need my guys that are monitoring it, I want them to get a notice. If it's off for 24 hours, I want an emergency response to go off because that is not the expected behavior. And then you can do many of these things where you're correlating what you're seeing in NiFi to actually doing counts on within HBase as well. So you can do multiple layers of validation.
I can check HBase later to make sure the counts line up. I could check it in flight. It's as deep as you want to make it for those validations and checks. I could do an upsert in Phoenix.
Yeah, that's actually a really good point. Is that so? Let's say if the reason why it didn't insert into HBase was say there was like a network issue, right? Say something happened or your ingest server went down. The data would begin to do something called back pressure. It would back up. And it would continue to have that data available that when you restore the network connection or you got the machine back up and running, the data that has backed up would not be lost. It would just continue to play back through the system and be able to be ingested into to HBase. Okay, we got to wrap it up. But any other questions?
Just for the NiFi and the Twitter, what API is that using? Is it just the free one you guys are able to get away with, or do you have to?
I have had people connect to the Twitter Firehose. So we support both APIs, and it's with the same one. Obviously, the Firehose, they give you special permissions, a special UR. But for the regular one, we're using that one. Obviously, if you have a government contract or something else, you could just plug into that. That's a lot of bandwidth.
Yeah.
NiFi can handle it. What we've seen is people run out of network bandwidth at their company. Yeah. You could saturate a T3 easily.
We are getting the hook to get off stage here, but thank you very much for your time. Both Tim and I will be available outside if you have any questions.